Hi, everyone. Thank you for joining us today. We're excited to welcome you to a fireside chat focused on achieving operational efficiency. Our discussion promises to be insightful, featuring two experts in the field. Our moderator today is Nikki Gonzales, host of the Automation Ladies podcast. Nikki will be leading our conversation with Noam Geffen, CaPow's Chief Business Officer, and Jamie Callihan, owner of JLC Robotics. They bring a deep and diverse range of experience to today's session. Without further ado, let's begin this exciting discussion on how to maintain peak efficiency with CaPow's Power in Motion. Over to you, Nikki.
Thanks, Rebecca. So good morning, everyone. Thanks for joining us. I've just heard about CaPow probably earlier this year when I connected with Jamie at JLC Robotics, and it's something that has come up in discussion quite a bit, and I wanted to learn more about it, and so it was a great opportunity to get to host this fireside chat to learn for myself as well as the community out there, kind of what it is exactly, what challenges is it solving, and how does it work, and get to hear both from kind of the OEM perspective as well as out in the field here in the US with Jamie. So I appreciate you guys joining us. I think we'll just jump right into it. I'm going to ask some questions and we'll get Jamie and Noam to discuss, and we'll see kind of where it leads us. We have a framework set up with some questions, and I know some of the topics we're going to dive into, but those of you in the audience, feel free to ask questions, and we may address them throughout the talk, or we'll have some time for Q&A at the end. We'll try to address all your questions. And if you don't get your question answered on the live today, you'll go ahead and get an email response from somebody within the next few days. So just go ahead and address, if you have a specific person that you want to address the question to, that'll be great. They can get back to you personally, or otherwise Rebecca will sort of figure out after the fact how to get you the best answer to the question and keep the conversation going. So if Rebecca, you might need to give me the ability to advance the slides. Although I guess before we get into the questions, if people don't know, who Noam and Jamie are, you guys should probably introduce yourselves as well. I'll go one down with Noam going first. If you want to give a quick introduction to anybody in the audience that doesn't know you yet.
Yeah. So first of all, hi, Nikki, Jamie. Thank you very much for hopping on this chat. My name is Noam Geffen. I'm the Chief Business Officer here at CaPow. I've been with CaPow for more than 2 years now. CaPow is the fusion of two words, capacitive power, and we are a deep tech company located out of the south of Israel, operating worldwide, but mostly in the US market. And we specialize on transferring energy to moving robots while they are on the go. Jamie?
Cool. Jamie.
Yes. Hello, everyone, and thank you for joining us. Thank you for hosting, Nikki. I've been in the manufacturing space for 31 years now, and as Nikki said, I'm more the feet on the street and listening to the pulse of the market here and the intermediary between CaPow and the thousands that we import. So president of JLC Robotics, a small business based in the Cincinnati, Northern Kentucky area. We import a Japanese AMR AGV for simple A to B handling from Japan called the Thouser. And we also work with CaPow, as Noam said, out of Israel to achieve 100% uptime for AMR AGV fleets.
Very cool. And I want to give, if it's okay, take a minute to explain. I'm in an Airbnb right now with a nice curtain background. It kind of looks like a hotel room, but I'm in the process of planning or kicking off an event for systems integrators in the OT space here in Houston, Texas. That starts tomorrow. It's called OT SCADACon. And we have just had crazy weather lately. We had a hurricane here in Houston a couple of weeks ago. We have had with a CrowdStrike outage or whatever that was last week. We're still having people delayed with flights. So it's very nice that this is virtual. Nobody is stuck in traffic or travel somewhere with their luggage lost. And I'm just very thankful to get to join you guys here virtually, while at the same time getting a group of people together that I know. One of the reasons that I jumped on doing this, even though timing is not great the day before you have a big event, but it's so relevant to the discussions that I am having at this conference with a lot of my colleagues and friends, the speakers, which are a lot of systems integrators that work with companies that have these fleets, that have these problems. We're talking about robots. So just wanted to throw that in there, that this is great timing, and hopefully we might be able to get you guys involved physically next year, or have some more information about CaPow for my audience there, but we'll make sure to share this information with them. But for those of you that are watching, anywhere, wherever you are. I hope you're safe. I know there's typhoons in Thailand right now. One of my coworkers is without internet right now there, and there's just a lot going on in the world. But this is such a great, fun subject that we're all very passionate about. And one of the things that these types of efficiencies can help us with is to try to make things a little bit more sustainable, reduce energy usage, make our operations more efficient. So I tried to focus on our little corner of the world and the things that we control, which is automation and robotics. So speaking of, what are some of the challenges that you guys have seen and that you're kind of responding to in the market around energy usage in automation, whether, in all its different facets? And maybe I will actually go and jump to Jamie first, let you give us your perspective kind of from the ground first, and then we'll kick it off to Noam.
Yeah, I appreciate that. As we started working with CaPow and learning about this, then going back to our customer base, if you will, which is automotive, packaging, it kind of runs the gamut of industries. And the thing that everyone's asked you if you've got an AMR AGV is, okay, how long does the battery last? So it's all about power. So it's unique that CaPow can give you 100% uptime, but the key buzzwords is a power to work ratio, and people will know that they're going to get a 4-to-1 or a 5-to-1 ratio of work, which means for every 4 hours that your AMR AGV is working for you, it's going to spend an hour on a charger. Well, that's going to lead into other things that they're going to need, which are additional robots, additional routes to different things like that. But in the challenges, a large Japanese OEM of vehicles, and they've got about a 55-second cycle time. What their pain was the robot having to go to the charger, and then think Roomba, right? You've seen your Roomba try and dock, and sometimes it would take 20 or 30 seconds for the robot to dock. And out of a 55-second cycle time, they were not getting the power that they needed. So that was a lot of frustrations for them. And that's one rubber meets the road challenge that our customers face.
Noam, you want to add to that in terms of what kind of brought you to want to take this challenge on? What challenges and issues are you seeing in the industry?
Yeah, so first of all, I fully agree with Jamie. I think he was spot on that, and I think the most pressing issue for operators was the work to charge ratio. And if I want to generalize that, I would say that basically you want to maximize your operational efficiency, but you don't want to prolong the return on investment, right? And when you look at that, energy is right smack in the middle with the hindering factors, because you always are in a position of energy starvation. You always need power. When you stop for charging, you're not earning money. And you can add to that the high entry barrier. So when you want to purchase a fleet, when you think about forming an automation solution, you need to think about buying robots, but then you need to buy 30% more if you want to have constant uptime. And you need to buy more chargers. It even gets to the point where when you want to place the chargers in the facility, you lose yield because those chargers take room on the floor. So all of that basically leads to the fact that operators today, they need to pay more to get the same throughput, okay? And sometimes it falls right from the get-go because the entry barrier is very, very high. And sometimes you just pay for that with just longer ROI. I would just add one more issue that is growing strongly and rapidly is the safety issue. The industry did a very good transition from lead-acid batteries to lithium batteries a few years ago. But along with progress, and now you got a much more efficient battery, you also inherited a safety problem because lithium batteries, and we all know that, they tend to get overheated and overvoltage, and these things can even cause explosions. Okay, we spoke to a very, very big grocery operator in the UK, the largest one, and he 2 years ago in the summertime had two distribution centers burned to the ground just because batteries just exploded. So right now they're paying more on the premium of the insurance. They're paying more than the actual cost of the fleet itself. So all of those things basically are hindering factors which are related to energy.
And safety is really a huge thing here. I mean, we can talk about ROI and all these things. And there are companies out there that focus more on that than safety, which is unfortunate because your people are ultimately, your advantage in the long run. But I was actually vetting one of the presentations for our conference yesterday. from Alicia Lomas. She's a process engineer talking about process safety. And she was showing us some examples of, she worked at a lithium battery recycling plant, and they had 2 fires due to the material catching fire, right? So it's not just about the hazard of the lithium batteries while they're in your facility, but then the entire supply chain that surrounds the batteries. I mean, these are extremely volatile materials. There is danger in dealing with them at every stage. So safety is a huge priority, and I think something that, particularly here in the United States, it is taken seriously. But working with these materials, there is a lot of hazards. So if you can reduce the amount of batteries, the size of batteries that you have, I think that reduces that risk assessment quite a bit as well. And it was very interesting. I didn't know, and I'm not going to get into specifics, but there's a formula that engineers can apply to this to see how much safety you have to implement based on the risk, and a factor like the size and number of lithium batteries in your facility. I'm sure CaPow's goes into that calculation somewhere.
Noam, would you speak to this as where we've seen that, especially the tier 1 in Michigan, where it gets to sip on the power. So we keep it in a happy range of, say, 40 to 70% charged, or 60 to 80% charged, which is where the robot really likes to be, versus you bring it down to 20%, and then you turn on a full-blown fire hose to try and ramp up your power as fast as you can. That's where you can run into some problems with overheating, etc. But that, if you would speak to that, Noam, and then also the capacitive versus the inductive.
Yeah.
Yeah.
Very good question. I think
as far as safety.
Yeah. Maybe we can also relate to that when we will review which kind of solutions are out there.
Yes.
So Nikki, maybe just hop on to the next slide.
Yeah.
And maybe first of all, let's review which kind of solutions are out there, and then we'll talk exactly about what you said, Jamie, because I think it's a very interesting point. I guess when you look at automation solutions today, how they charge, okay, the immediate suspect, or the, let's say, the solution that most of them use is connected charging. Okay, it can either be automated or manual, with someone just comes and sticks the plug in. The advantage is very, very clear. Okay, it's easy to implement. It has a very low complexity. It's a low complexity solution. But on the other hand, you gain nothing in terms of energy savings and energy efficiency. If the robot needs to stop and get plugged for charging, then safety is not very good, because you have open connectors, and energy efficiency is not going to get better, right? In recent years, we also see the transition towards wireless charging, okay, which improved safety a lot, because right now we don't have the open connectors, but still you are remaining with the downtime. If you need to stop, and with wireless charging, you need to be very, very aligned. If you miss the charging the spot by 2 centimeters, you will not get charged. So right now you still need to stop. Okay, so still energy efficiency is not that good. And related to your question, Jamie, the way that companies are dealing with this shortage today is basically to produce faster chargers and larger batteries and stuff like that. But when you charge the battery faster, you actually ruin it. Okay, the life expectancy becomes immediately much, much shorter. Okay, if you charge it with what we call 2C or 3C, where C is the measurement of charging the battery fully in 1 hour. So if you charge it with 2C, it means you charge it in half an hour. And if you charge it with 4C, you charge it with 15 minutes. But then you ruin the battery 4 times as much. So the ideal way is to charge a lithium battery at half a C, okay, to charge it slowly, and to charge it always when it's at 70%. Not charge it from 80% to 20% like we do with our phones, but try and keep it as steady as possible. Another solution that we see in the market today is battery hot swap, okay, which solves the downtime problem quite dramatically, right? You just take the battery out, put a new one in, and drive safely, everything is good. But then, when relating to the safety problem, you actually triple your safety hazard components, because right now you have 3 times as much batteries, and there's an operation between an operation, and there's a lot to take into when you do this kind of solution, and it's quite costly. So remember the initial ROI we spoke about, it's not going to get any better.
Yeah, we actually, before we knew of CaPow, we actually, for our AGV that we bring in from Japan, it has lead acid batteries. So that's great, because people can use them for a couple of years and then go buy what they need at Walmart to replace them. But the people or the companies who need a lot more uptime, if you will, that's not going to work so great. So we started looking at the lithium ion and then the wireless charging that was out there. And there are some good products out there. We can't really knock them, but as Noam said, you still have to stop. But the other challenges were that you really have to get aligned pretty well in your X, Y, and your Z. If not, you're going to not be as efficient as your power or not get power. So you really had to get your AMRs to line up real well. And I was told from another OEM automotive company that for their skilled trades to drop power from 480 down to 240 or what have you, that was pretty expensive for them to excavate and all these things that they need to do, which is where CaPow, you can plug it into 110 volts and still get what you need. So we haven't touched on that yet, but
No.
again, there's some good ones out there, but as Noam said, you're still having to stop the charge, and you really have to be aligned well, which I guess later we'll talk about with CaPow alleviates some of that. And that's what, once we seen CaPow and started talking with Noam and the team, we had actually bought a system from one of these wireless chargers, and we left it on the skid and sold it back because we thought that the future is CaPow. We really believed in it, and so we went full bore with CaPow.
Very cool. So with that, do you want to dive into showing us a little bit more about what CaPow is all about, or do we have any more points or questions you guys want to bring up before doing that? Because I'm pretty excited to see this.
Yeah, so maybe let's review high level the solution, and then we'll talk about the advantages, and then I'll try to see if these advantages actually ticks the boxes that we mentioned earlier. And yes, so what we try to do in CaPow is to enjoy, or to combine the best of all worlds. Okay, the idea is to charge the robot while the robot is moving. Okay, and not just moving while the robot is en route. Okay, the benefit, of course, is immediate, and it's very, very clear when you charge the robot while it's moving, and it can be any kind of robot, right? So we are completely hardware agnostic and can work with any kind of robot and any make and model. It can be ASRS solution, AGVs, AMRs, drones, what have you. The idea is to charge it on the go. You get 100% uptime, so you never go to charge. Okay, CAPEX immediately becomes much better because if you charge on the go and you get 24/7 solution, then basically you don't need additional robots, you don't need additional chargers. Okay, even the infrastructure right now is completely moderated in the fact that it can work with several different kinds of robots on the same platform, right? So usually the first questions I get is how long this antenna needs to be, right? Because if I charge it, do I need to have the entire facility covered? Do I need to have like 100 feet of an antenna? The idea is for us to change the concept. Instead of charging 4 hours, working 4 hours, charging 1 hour, and then you need the 2 kilowatt hour battery, which is huge and very expensive. Think about pulse charging, okay, or trickle charging. You give, like a Mario Kart game, right? You give a pulse of energy, okay, 30 seconds, one minute, okay, and it should last you for five minutes or 6 minutes off the antenna until you get the next one. So if you work in those sips of energy while en route, and I didn't mention, but the antenna can be very long, very short, narrow, rectangle, round, on the floor, on the side, what have you. When you do it like that, all you need to plan is to get to the next one. So the battery can be spec'd down from 2 kilowatt hour to even 400 watts or 300 watts, or in some cases, completely eliminate the lithium battery and replace it with a small supercap. And in this way, you get 100% uptime, you get much lower CAPEX, and your operation is stuck on 100%, as we like to say. Your throughput is constant all the time. That's the concept.
Yeah, we actually have one of our thousands fully CaPowered, which means we're running supercapacitors. We're not even running batteries anymore. So it's very cool. And if it worked out for a customer where they don't have to have someone knowing where the lithium ion batteries are coming in, going out, can alleviate some red tape, and I guess the government or state side for customers.
Yeah, and Jamie, I think I shared that with you also. We had an OEM from Northern Europe, okay, approach us and say, we are developing a new kind of robot. Okay, it's like a overhead hoisting system, and it It's the first time that we design something like that. And the problem with us is, as an organization, we don't want to deal with lithium. Lithium is a problem for us. We don't want to start storing it, sending it all over the place, refurbishing it.
Yeah.
It's actually pushback from the logistics department. It's not even related to product management. As soon as we plan that, logistics approach and say, no lithium in this organization. And what we did is we spec'd down the battery in such way when they introduced CaPow that they completely replaced it also with the supercap. So they didn't even introduce lithium into their system. So from the get-go, you can either plan for the solution to be like that or retrofit a current solution, okay, aftermarket, into that.
Yeah, I was about to say, so you could retrofit if you had a fleet already of different robots. Is that like, what kind of ballpark costs are we talking about a retrofit of taking out a battery and installing a supercap? Jamie, can you speak to that?
It's a little difficult to say because it depends on the robot, but what we've seen is roughly what you're doing, it's less than 2 hours for us to change out the antenna, or excuse me, to incorporate an antenna and make the necessary changes within the robot. So it's not terrible.
And then that's really an ongoing cost savings though after that. Like I would assume the ROI
Correct.
is pretty quick.
Yep.
Yes. Yes. So we've seen that some customers, if they have, they don't always have 100 robots. If they've got 7 robots, but they can power and they can drop it to 5, well, then they can utilize those 2 somewhere else to do other work. And so, yes, you're right. You can get your ROI pretty quick. As Noam mentioned, and it's in the video, the floor planner helps us calculate that ROI and the cost of what we need to do.
Yeah. Have you seen, can you speak to maybe some examples of people that you've worked with that have done that type of, retrofitting, if they were able to, like, what are the results of implementing CaPow? And if you have worked with anybody that's kind of retrofitted away from batteries or made smaller batteries, I assume there's less storage space that they need. They can utilize more of the floor space. They don't need charging space. There's a few positive operational changes, I would guess, when that happens. Yeah, perfect. Okay, next slide.
There you
Yeah,
go.
so it's an excellent question, like we like to say, because it's the next slide.
Yeah.
So in terms of the battery regime, okay, so basically we leave the decision up to the operator or up to the OEM. You control your destiny, you control your energy roadmap. Some of them that we did retrofit like to stick with the same battery, okay, and say, we're not going to do a revolution, we're going to do an evolution. First stop, work with the existing batteries, and then we'll work with that. To that thing, I should relate and say we already have an advantage, because once you stop charging it or discharging from 80 to 20 and then 80 to 20 and strain the battery, we immediately give them what we call 3x. So just by using CaPow, you prolong the existing battery life cycle by something like 3 times, just because of the method.
Wow, yeah.
Yeah. So that's the immediate gain. Another OEM decided to do a spec down, just as we said, and instead of using 1.5 kilowatt hour battery, he started using 600 watt hour batteries. Basically, the cost of that was around 30%. So the difference is, between like $2,000 and $600, something like that, just on the battery. And of course, it gave it more room inside the AMR, because we know that inside the vehicle, real estate is very, very, very scarce. And just as Jamie mentioned, both with the Thouser of JLC and with the operator from Northern Europe, the OEM from Northern Europe, we did a complete lithium battery elimination, and we replaced it with a supercap. CaPow, as I said, we work with all kinds of robots, but we also work with all kinds of batteries and battery banks. So for us, it doesn't really matter which kind of battery you select. Okay, we can recommend, but you choose, we will implement it. It's very easy. This gives you immediate benefits both on logistics and on safety, as we said. And coming back to the immediate suspect, CAPEX, okay, once you deploy CaPow, immediately you reduce something like up to 30% of the cost of ownership. Okay, so when you look at the cost of ownership of operators in the automation solution, the amount of robots per fleet makes a lot of difference. The cost of chargers, the cost of batteries, the cost of real estate in the warehouse, this can all be avoided either from the get-go or while doing a retrofit. We see also a very big gain on the operational efficiency, okay, on the OPEX. So when you use less robots, queues become much more ideal, okay, much more efficient. and there's no what we call to and from lanes. You don't need to go to the other side of the facility to charge the battery. We actually had the case study of this tier one manufacturer that Jamie mentioned from Michigan that came back to us after 4 weeks and told us, listen, the entire production loss of the facility, okay, the robots, okay, or automation causes 4% out of it. So automation accounts for 4% of the entire production loss of the facility. And just by deploying CaPow, we saved 50% out of that. So we were able to reduce the entire production loss of the facility from caused by robots from 4% to 2%. It's a huge saving. It's huge savings and can be done just by optimizing the way that you approach energy.
Yeah.
Yeah, there's a new
Jamie?
one that there's a new one that I just heard of about 3 weeks ago, and we're actually in talks about doing a POC with this particular vehicle OEM. And somehow they're going to have new lines where these lines are enclosed. So imagine now you've got AMRs inside of this enclosed area. How do you get them out to go charge? How do you put a charger? Where do you put it? So they are super excited that with CaPow, it's along the floor. It's just going to run over where it needs to run over, and they're not going to have to exit that area. So that was a really cool one. And then another company that we're in talks with that, and I don't know why, but the guy was saying he was going to have to buy 3 different brands of these small forklifts. One was good, maybe from 0 to 5 feet, 5 to 10 feet, and whatever it was. But he was really happy he didn't have to have 3 different types of chargers because, as Noam said, it's brand agnostic. We really don't care if you have a mix of AMR brands. So that can create it where you don't have to you get into the floor space, the traffic, 3 different brands where you got 3 next to choke. If there's a problem, now you only have 1. So that's our customers and engineers really like that a lot.
Yeah, I know I at home like having wireless charging instead of having multiple different, connectors that you have to use with people's different preferences for phones.
Correct. Very
yeah,
strong.
and like getting people to standardize, it's very hard. So doing something like a third party, right, where you don't have to worry about convincing everybody else to standardize, you can actually just retrofit if you already have a bunch of different stuff, which, let's face it, most facilities out there that are implementing AMRs or, AGVs or, more of these robots, they've already done POCs in the past. They've already tested probably a couple different types in smaller quantities before they're going for big deployments. Yep. Why not give them the opportunity to participate in the fleet, I guess? Like there's middleware now, like SVT Robotics, that allows you to give instructions to different types of robots through one software, right? And this seems very parallel to me, but on the energy, on the charging side, right? I can't really think of a reason why you wouldn't want to standardize the charging and make it more efficient and save the space, save your battery life, reduce the safety hazards in your facility. It seems kind of like a no-brainer. So I'm sure there's a catch somewhere. We have a few questions. I don't know if we're ready to dive into those or if you guys have some more stories that you can share.
Yeah, just Nikki, I wanted to relate to your last comment, and I think it's brilliant that you mentioned that because if you think about it, energy is basically, you can actually sell it as a service, right? Energy is a service. Just like you have companies, right, that right now are going towards robot as a service. Okay, just you're gonna lease the robot. You can do the same thing with the energy. Okay, even to the point that today you're launching a specific robot solution, and tomorrow you're transitioning to a new one. Basically, because the CaPow installation is so robust and it's headache-free and it's very easy, we just connect to the plus and minus of the battery. You can actually take the solution from your legacy old robot and then just plug it into the new one, right? You can actually treat it as a service, basically. I think it's a concept to consider.
And I think that, to your point, Nikki, a lot of people do not know that this technology exists, and that's our role, is to get out and educate people. And then as people want to have conversations to see if it's good for their facility, that's where they find out if it is or not. But it's just so new. Again, there's nothing like it in the world, and that's why we're having this webinar and being on LinkedIn and trying to jump up and down and say, hey, there's a new way to do things. So
yeah, and I think that in our world that can be very exciting, and at the same time we hear a lot of all of the automation vendors, they release a new thing, many of them, like every quarter. There's always somebody shouting new, and most of it's not really new. It's an improvement on an older product, or it's there's not very often per year that I see something that really makes me go, oh yeah, I didn't know that existed. Like, obviously cobots are huge. They've been around forever now. They've become more mainstream, just like AMRs. But the first time I saw a pneumatic cobot, I was like, oh yeah, cool. Didn't think of that. Like, nobody's done that. I don't think anybody's done that. Festo released that a while ago. But then when Festo releases, a new, manifold, to me,
Right.
unless I'm like a manifold designer normally using it, it's not that exciting. This to me was something that caught my attention as something legitimately new and different. And I am a startup kind of person. I like to see what's new, what's cool. So we have, a bit of on my podcast, I normally interview people about their journeys, their types of jobs. I want people to get to know the automation industry, what it looks like, how everybody, can have fun in it. Although it's extremely challenging at the same time. But we are perpetually curious. And so we've started to do these demo days, which we've done a few online demos of kind of newer things. But obviously software suits itself better to online demos. Engineers need to kick the tires of things, especially physical things. So I'm sure, Jamie, you probably have kind of an open invitation if somebody wants to come check this out. They at the very least could come to your facility. Do you want to talk a little bit about that, kind of what you have to offer, what you can do with people if they want to, really see this thing in action?
Yeah, we actually have the fully powered with capacitive chargers on the Thouser, and then we also have a mirror to show it's brand agnostic. We have the business housed in Northern Kentucky, 10 minutes or so from the Cincinnati, Northern Kentucky airport. And if anyone was interested to come and see this in person and have conversations, we would welcome that for sure.
Well, I think I'm going to go ahead and commit my friend and partner, Courtney Fernandez from Automation Ladies, who is our resident robots geek, to come see it and visit you. And then at the same time, it might be very interesting to see if we can get one in our LA facility for the West Coasters to be able to check something out. But anyway, lot of exciting things. We have again, we have some cool questions, so I'm glad people are engaging here.
Yeah.
If you guys are ready, I can move on to some of those and we can kind of keep the discussion going.
Let's do that.
Okay, so first of all, we got one that just says sounds interesting, so that's good. Thank you for commenting. I'm glad you're interested. Non-interesting fireside chats or webinars are the worst, right? So I'm glad if you spent 35 minutes with us so far, hopefully it was at the very least interesting. Okay, so here we have another one. Can you speak to human safety, specifically when bots are entering and exiting the pad and a human steps on or near the antenna pad?
Yeah, that's an excellent question that we get a lot. The idea and the concept, a part of the technology that we implemented is that even if it's a 30 feet long antenna, okay, only the part which is underneath the robot is electrified. So if the robot is now on a certain side of the pad and right now the energy is being transferred, you can stand next to that. You can drop things on the floor. You can just cross its path and nothing will happen, because only just don't stick your hand between the robot and the antenna on those 2 centimeters that you have. But don't do it with your socket at home as well. But other than that, you can stand on the antenna. It's perfectly safe. And this pixel method is something that is we implemented just because of safety. Another safety mechanism that we implement is basically man in the middle. Okay, and if we sense that someone is going to stick his hand or something like that, the energy transfer will immediately stop. Okay, this is also something that is mandated by standards like EU and UL. Yeah, so
Noam, I can't remember the 2 different certifications that CaPow went for, but CaPow for the one that was way more stringent than the first one. And I think that goes along with what we're talking about here. If you know what I'm talking about, would you enlighten and speak to that, please?
Yeah, sure. So when you approach both CE certification, which is required in Europe, or UL certification, which is required in the States, a part of that is just to show how the electronic field is decaying and why is it not dangerous. And there are 2 standards. One is for let's say facilities and operational centers and guys who are engaged in automation, which is like 600 volt per meter, the decaying field. Another one is just for the normal person. Okay, and this is more strict. This is 140 volts per person. We are much lower than in both cases. So when we do the certification, we dress to the most strict one. and still we are very much underneath that. So in terms of safety, both in how the field is spreading, how much heat are we transferring, how much are we interfering with other devices, because a robot is full of gizmos, and we don't want to ruin the LiDAR just because we transferred energy. So in all of that, we are completely safe, and your equipment is completely safe.
Very cool. The same person it was a two-part question. So also, if I move to SuperCap, how long does it hold a charge? And what if my employees forget to turn off my bots over the weekend and come back on Monday morning?
So again, it's a great question. And when we looked at SuperCaps, the reason we chose it when we wanted to reduce lithium batteries is that it has a certain qualities and abilities that really tick this box, exactly what the question was mentioning. One of them is that a supercapacitor, the number of cycles, is within the millions. When a lithium battery holds something between, I don't know, 10,000 cycles, maybe 12,000 cycles, a supercap holds 2.5 million cycles, right? So it's much more energy dense, which means you can deploy a much smaller and more cheap solution in order to provide for a bigger battery or to replace a bigger battery. Another thing is that it can hold the voltage without any loss. Basically, you can take a supercap, charge it to 100%, turn it off, come back after 1 year, and you lost like 0.003%, something like that. So as opposed to lithium battery, which still discharges even if it's in storage. If Jack forgot to turn off the radio, the robot on Friday night, what happens usually is you are on idle mode. Now supercaps, usually when you do the solution, you tailor two supercaps together. One has the properties of holding the voltage, another one has the properties of holding the current, which means the system knows how to differentiate if the robot is now in idle mode. So it will shift like your like hybrid car. When it senses you're stopping in the traffic light, it will shift to electrical, right, and not use petrol. So it's the same thing. So on that, it also has a major advantage over a lithium battery.
Very good.
That's a great question, and let me flip it also, because we had been asked from our friends at the OEM vehicle plant, what if I leave my robot on the charger, or Bob leaves it on the charger on Friday night, or we go away for a long weekend or shut down, what have you. And so, Noam, if you would talk about how the system takes care of that, that would be great.
What? Sorry, can you repeat that?
So if someone leaves the AMR on the charger on Friday night, it's at 72%. They leave it on there. Oh, I forgot I left it on there. Speak to how it would safely.
So the system, first of all, and that's interesting in terms of how the system is built. We don't have any communication between the receiver and the transmitter. We don't complicate the system with also data transfer or something like that. The only thing is that we are waiting in pilot mode, and whenever the system is sensing, a consumer on top of that, then energy will start flowing. And then we also have thresholds in the system that says if you are charged above a certain threshold, stop charging. If the system senses that now that you are more than 80%, it will stop charging. And then you have a lower threshold. As it drops below, it starts charging. This way, you can always ensure that you are between 70 and 80, and you're not straining the battery, and you're not charging while it's already full.
So since they had that great question, I thought that's the flip side that we had also been asked of, well, what if I do leave it on the charger? So both ways were covered.
Yeah, these are great considerations.
Yes.
Is the supercapacitor solution being accepted as a viable solution to batteries, or will there need to be a longer education period before customers are willing to change from legacy battery systems? I guess what's your experience been bringing it to market?
Yeah, so I think the market or the ones who are aware of lithium difficulties embrace this kind of a solution. So, you don't know what you don't know. And if you're not aware that if this is the solution exists, then you live with all the pros and cons of lithium. Right. The price of supercap, gram per gram, is more expensive than a lithium battery. The thing is, and thus, a normal operator will not switch a 2 kWh lithium battery with a 2 kWh supercap. But if you combine it with a CaPow solution, which means you need 1/10 of the size of the battery, now it cost-wise, it's much better. And of course, as I said, logistics-wise, it's also much better because the UN 38.2 standard states that it's 1 degree below lithium in terms of hazardous material. So in that as well, whoever is getting acquainted to the solution and is willing to do this leap embraces this kind of a technology.
Okay, very good. Thank you. Next, we have a question about what are the advantages compared to inductive?
Oh, that's a super question. So I think the one thing that capacitive power, and again, capacitive power has been existing ever since Nikola Tesla invented electricity, okay, or found out about that. So capacitive power is not something new. The advantages of capacitive over inductive is, first of all, what we call metal in field. If you have metal debris or just a piece of metal within the antennas of an inductive solution, it will get superheated, okay, to the point that it's a hazard, basically. With capacitive power, no. In capacitive power, it will not get heated, and also the tolerance, the amount of height, okay, or the air gap you can have between two antennas, okay, is much more of an advantage in capacitive. On top of capacitive power, CaPow itself has lots of patents, okay, that allows us to take the disadvantage, or either to eliminate the disadvantages, or to turn the advantages to top-notch ones. For example, and Jamie mentioned that earlier, misalignment, okay? When you are able to transfer energy to the robot while it's moving, you are also able, or it mandates that you will be able to transfer energy even if the robot is skewed to the side or parked 3 inches to the left or something like that. This gives us, even in stationary situations, gives both capacitive power plus CaPow a major advantage over traditional inductive solutions.
Okay. Alex says thank you. Thank you, Alex, for joining us. We appreciate you.
Thanks, Alex.
Is there a weight limit on the antenna?
Yes. So again, that's a very common question that we get, because if you deploy an antenna in the vicinity of forklifts and tuggers and service cars and stuff like that, you need to be able not to replace it every 4 months. So the current standard for the antenna, what we call 22 megapascal. Okay, and if we translate this into day-to-day words, basically it means a 9,000 pound forklift going over the antenna 500 times a day for 5 years. Okay, this is how much it will take to win this antenna. Okay, of course, it also has other parameters like how wide are the wheels of the forklifts. Okay, but generally speaking, even a narrow wheel forklift, no problem.
This actually brings up a question of my own. I hope that's okay to throw that in there. But what is kind of the life cycle of the antennas look like, mean time before failure, and then what do you do? Can you just replace the antenna in the mat? Do you replace it with a new mat? What's the maintenance and kind of life cycle information if you purchase these and have them at your facility?
Good question.
Yeah, so the antennas should be durable for at least 5 years, as I said. So 5 years is currently more than the average life cycle of a robot. So if you buy a robot and deploy CaPow, most chances are that the robot will get out of commission before the antenna will. And if you want to replace the antenna, basically you have two options. One is to just replace it, one with one, just completely, because when you deploy the antenna, and that's something we haven't mentioned, but it's worth mentioning. There's no excavation, there's no specific mounting, there's no adhesives or stuff like that. You just place it, so you will be able to change the layout. So if you want to replace the antenna, it's one by one. Basically, it's very easy.
Very cool.
Yeah, the entire installation, by the way, retrofitting a robot takes less than 1 hour. Placing the antenna takes less than 1 hour. It's relatively quick and painless.
Yeah, so the installation is very light. What type of, do you need resources from any trade, or can somebody's like staff just do it? Do you have any in terms of requirements and planning for an installation?
From the installation, again, we have 3 tiers or 3 options. First one is CaPow can come and install it for you, okay, if you really want to. But we feel and we work a lot through distributors, okay, just like JLC, okay. And today, when we want to deploy with this tier 1 operator in Michigan, either our distributors and resellers like Jamie can come and immediately install it for you. In some cases, the customer itself can install it, because as I said, the installation is very easy. We have very good manuals and installation guides. And basically, we send the equipment to you, you take it out of the box, you plug the receiver to the plus and minus of the battery, the antenna on the floor, and you're good to go.
So it's very flexible. You could work with the systems integrator or do it yourself or work with the distributor. That sounds great.
Right.
So like you
As
said,
you know,
with the
Nikki,
other types of things, you
white
have to get
gloves.
you have to get electricians on the schedule. You have to pull cable. You have all kinds of
Right.
permits. That really increases the cost as well as just the timeline of getting something like this installed.
As you know,
And
different companies have different horsepower internally. Basically, I would
yeah,
say as long as there's 110 volts nearby, yes, they can do it themselves, or what Noam had mentioned.
very cool. We got one last question I think we have time for, and then we can wrap this up. Is the system that senses battery charge level something in the cloud where bots have to communicate via an API to convey their charge level? So is that local or is that, yeah?
Yeah, it's completely done by the receiver itself. Because the receiver is plugging to the plus and minus of the battery, imagine that we are now connected to the rail of the robot in parallel with the battery. So whichever voltage and current that the battery senses, we sense the same thing. So when we want to set a threshold, it's actually immediately what the receiver sees at the output of the battery. So no need to go to the cloud. We do have a software service, okay, available also locally that you can see exact or aggregate a lot of data and extrapolate and do manipulations on the database and understand a lot of stuff. But the basic system does not require anything like that. It's completely auto-sensing inside the robot.
Okay, I was about to say, so if someone doesn't want to add, 100 more devices to their network, clogging up traffic and all kinds of stuff like that, creating cybersecurity issues, you could keep it completely contained and local.
Exactly. As we say, we worked very hard to keep it very simple.
Very good. And then I guess there's one more question. That's a good thing. We got some engagement here. What type of power supplies power the antennas, and can existing infrastructure connect to the antenna? So I think we kind of answered that, but if you want to just reiterate the answers to this question.
Yeah, so the transmitter that transmits the power to the antenna can either be powered by AC voltage, okay, from the wall, or from DC. We currently support 12-volt DC to 60-volt DC on the input.
Okay.
So it means basically every kind of facility that has DC is acceptable, and of course AC from the socket, 110 to 20. No problem.
Very good. So it sounds like you can very easily connect this to any existing infrastructure, pretty much.
Yeah.
Retrofit any type of facility.
Side, sorry, go ahead.
Oh no, I was going to say, and then you can really reconfigure them as you need to. So I guess when you first design your solution, I'm assuming that they're, like you said, that the mats can be different sizes, right? The antennas. So are there standard selections that you choose from, or is it custom sizes?
Yeah, so both, because we worked with lots of robots in the market, we now have standardized most of them, okay, to 3 specific sizes that usually we use. But if someone needs specifically to customize it, then it can be tailored very quickly. Just to add to what you mentioned earlier, as we said, on the input it's 12 to 60 volt DC, but also on the output of the robot. So if I have 2 different kinds of robots, okay, one has a 24-volt rail and another one has a 48-volt rail, the system will auto sense and adapt immediately. We don't need to pre-configure that. So as I said, if you take a system from a 24-volt robot and you put it in a 48-volt robot, it will work seamlessly.
And along with that, we at JLC are trying to position ourselves to be CaPow West, because Noam and them are great. They're 7 hours ahead of us, and he's some kind of vampire. I mean, you can text him at 4 in the afternoon and he just pops up and doesn't sleep. But anyways, we're in talks to have some of the common sizes and things, transmitters, everything we need at our facility close to the Northern Kentucky Cincinnati Airport, where again, if a transmitter was to have gone bad, we don't have to call Israel, wait for it to ship. It's, hey, we're going to get this out right now and you'll have it tomorrow type of thing. Because we know that customers aren't going to be happy if we have a long discussion and timeline to wait for shipping and things. So
yeah. So obviously for spares, commonly stock sizes, things like that, you'll start to see some presence here, which is great. You need to be able to get those things like overnighted sometimes. Although hopefully these things are not that expensive that people could have maybe a couple spares in their stock room.
Yes.
Since they're so quick and easy to replace. That way, if something goes, down, you can just hot swap one and, see what's up. How long does it typically take? Let's say I wanted to place a new order for my facility. I'm doing, some custom sizes or some commonly stocked stuff. What does the lead time look like if I'm ordering from Israel?
Well, you are ordering from Israel, but thanks to Jamie for we have lots of equipment already in the States. Okay, so lead time will be between 4 to 10 weeks, depending on exactly what you need. Okay, but some of the solutions are already on the shelf. Okay, but let's say on an average, it's 4 to 8 to 10 weeks.
Yeah, I'm sure. I mean, if somebody's doing a larger scale installation, that's something that would be on order rather than maybe taken out of stock.
Exactly.
And then, as far as maintenance, operations, all that kind of stuff, it doesn't seem like people would need a whole lot of specialized training or support or anything like that. It's meant to be very easy to use, straightforward. Do you have, online videos, resources, things like that for people that are working with them?
Yeah, so we have complete collateral, first of all, on the marketing side, if someone wants to dive into the solution, a little bit more on the ROI side and see how it can benefit you guys. It's available. We can also do a discovery session. It takes less than an hour, and after 1 hour, we can immediately show you how many antennas do you need in your facility, what will be the overall cost, and what will be your cost of ownership savings. This can be achieved in less than an hour. And on the technical side, we have lots of documentation like installation guide and technical Q&As. And of course, whoever wants to do a deeper dive into the technology, all three founders of CaPow are doctors for electrical engineering. Our CEO is a professor, world-renowned for power electronics. Whoever wants to dive into that rabbit hole, be my guest.
Okay, yeah. Sounds like a topic for another discussion, or those that want to dive in more. Get in contact with you guys. I'm sure you guys are all on LinkedIn, right? Open to connecting with those that are in this space and could use these solutions. And then contact you guys for, a little demo, right? To go through your use case, get pricing information. Do you guys have any kind of ballpark pricing information available publicly, or is it pretty much, kind of you need to have that call first and then give somebody an idea of what their system would look like?
Yeah, I don't want to speedball something which is very, very ballparky, and eventually it will be tailored. So it has a few variables. I can say that in all discovery calls that we've done, it's easy to show that it makes sense. Okay, cost of ownership is reducing in such a way that CaPow still shows the equation is highly positive.
Okay, we have 3 more minutes. Thank you so much, Nikki, Noam, Jamie, and thank you everyone for joining us today. If you have any more questions, feel free to send them our way. We'll keep the conversation going through email updates. We appreciate your participation and look forward to staying in touch. Have a great day. If you want to investigate further, CaPow.energy is your place to go. And again, I'll be in touch over email in the next couple of days. So thanks a lot, everyone.